Oh, it's history time! Okay, so I am by no means a history aficionado in the world of physics or sciences in general. And if you are interested in the or the actual history behind some of this stuff, like I encourage you to pick up some books, browse the interwebs, take a deep dive into it because it's all like highly interesting. It's just not stuff that we really get very deep into within this class itself. But this is interesting enough to spend some time talking about it, and it deals with the history of radiation in and of itself, and how we kind of stumbled across the idea of radioactivity and where it kind of led. So, the story of radioactivity in and of itself begins with Becquerel, Henry Becquerel, or Henri Becquerel. He's a French physicist. And in around 1896, Becquerel, as a astronomer, or using photographic plates for astronomy, and the way these plates work are essentially they're photosensitive plates. So when they're hit by a speck of light, the plate darkens in that spot, so you like see the star, right? So these are like blank plates, and then you hold them up into the night sky. You set them on your telescope and whatnot, and then the light from all the stars out there comes down through your telescope, and it hits these plates, and the energy from those photons, turns the plates a darkened color. Um, Becquerel had these plates covered, and when he set them down once, he started to notice that the plates just turned foggy. Like they just got hit with a bunch of light, which they couldn't have. They were completely covered. What the heck? This has never happened before. And it turns out that what he set these plates down on was a radioactive substance. He set them down on kind of like a salt of uranium, if that makes sense. Probably doesn't, but that's the general idea for it. And it turns out that this radiation had enough energy to cause these plates to darken and to turn. Even though you couldn't see the radiation, it was there. So Becquerel has this idea that something is going on here with these rocks, with these minerals, that they're releasing energy in some way. They are radiating energy, radiation. Um, Becquerel, we have the Becquerel unit named after him, or as it's commonly called, Bex. It's really just a counting unit, but it's interesting nonetheless. But Becquerel went on in his career to start looking at a lot of stuff for medical research, investigating radiation. And interestingly enough, Becquerel ends up dying at age 56. Although the cause is unknown, he had a large number of burns on his skin. These burns are more than likely radiation burns. There's actually a story of he took a piece of uranium once and left it in his vest and forgot about it. And when he took it out, it had burned his skin like through all of his clothing. And that was actually the start of using radiation in medicine to try to treat cancers and whatnot. So very interesting stuff. But really, in this early time, like he didn't have any idea of what he was playing with. The science was being done to discover it, and as a result, probably died a little earlier than he should have. But while Becquerel was the first to kind of like stumble across radiation, Becquerel was is always kind of like thought of as second in comparison to this lady. We're talking about Marie Curie. Um, Marie Curie and her husband Pierre, they did a ton of work in the field of radiation. They ended up isolating highly radioactive polonium and radium. Um, and unfortunately, her husband Pierre died in 1906, just 3 years after they were both given the Nobel Prize in Physics for their work in radiation. He was age 47. Can you guess what killed him? She died in 1934 at the age of 67 through some anemic thing. I'm not a medical doctor, so like I'm not exactly sure, but it's highly believed that her diagnosis was a result of all of the radiation that she played with over the years. But she is like not only the first woman to ever win a Nobel Prize, she actually won two of them. The one in 1903 with her husband for physics, one in 1911 for chemistry, and then the Curie name is actually a legacy of Nobel Prize winners. She won the physics one with her husband, so that's two in the family. She won a chemistry one. I believe her daughter won one in what was it? Maybe physics or chemistry, and then Her second daughter's husband was like the leader of UNICEF and won one for just a Nobel Peace Prize. So like the Curie family legacy is filled with Nobel prizes. They really know their stuff, and they really really work hard on what they're doing there. So interestingly enough, though, in terms of early radiation, um, we kind of stumbled across it. People like Becquerel, Curie, the Curies started playing with it. And by playing, we mean doing very precise scientific research on this newly discovered thing. There were others working at this time, but those are kind of the big hitters right there. But in terms of safety, we really didn't know what radiation was doing. We didn't understand the energy levels about it. We didn't understand the possible dangers that could exist with it. And it was through the sacrifices of these early researchers that we've really started to understand, like, hey, this energy coming out, this could be, possibly dangerous. And in some cases, it very much is in higher doses. These ionizing radioactive particles, can kind of damage the human DNA, leading to things such as cancer. So it was this early work that kind of gave us this stuff. But from it, we've been able to do so many things, not even just in terms of understanding radiation and radioactive substances, but in terms of nuclear power, the classic atomic bomb, through World War II and the Cold War. Although that's probably not a great thing there. And then also within, through Becquerel's work early on, and then from that, using radiation in medicine, either for tracking devices like we talked about with PET scans earlier on, or if you are trying to do chemotherapy to try to attack cancer cells with some radioactive isotope. So all very interesting stuff, and it only started just around 100, 120 years ago that we really started playing with it. So very much this idea of nuclear physics is a very, very young science in comparison with many other things that we're aware of. So that's just a little bit of historic background. Like I said, if you are very interested in this, like you can find so much information. There's information that goes into the atomic bomb through World War II, and how we used to paint clock hands with radium, and the women who would paint these clock hands, they'd lick their paintbrush, they'd like lick radium. Just wild stuff. So if you're interested in this kind of history regarding nuclear physics, it is very young, it's very right there, and I highly encourage you to dive into it and see where it takes you. Next time, what we're going to start looking at is we're going to start seeing where this idea of radioactivity takes us for alpha, beta, and gamma decays, and what we can see with these decays, how we can analyze them, and how we can eventually work into fusion and fissions for nuclear in and of itself. Until next time, though, adios and take it easy.